Are you interested in data science? The primary data structures in data science are the numpy array and pandas data frames. So in this video, we've got an introduction to the numpy arrays and the pandas series and data frames. Now, numpy arrays use less memory and are faster than Python lists, so we can perform operations on the numpy array more efficiently. Panda data frames are like tables with rows and columns. They're very good at cleaning, transforming, manipulating and analysing data. They use in-memory computation, so we use the data frames with the numpy arrays. The frames are ideal for small to medium-sized data sets. Now, the data frame is made up of columns, but these are called series, so each column is a series. So let's focus on numpy. Numpy is numerical Python, which is a scientific library where we look at arrays, either one-dimensional, two-dimensional or multi-dimensional. And we can perform operations on the elements, the items within these arrays quite efficiently. So we can read and write, and we can perform linear algebra operations on the data, and also good for integration. So numpy, very useful for applying operations on large quantities of numerical data in a form of, if you like, dimensions in arrays. Sounds a bit confusing, but we've looked at arrays before in Python. We looked at lists, which are quite similar, but just not as efficient as a numpy array. So what can we do with a numpy array? Well, here's the code to create a simple numpy array called data. We print it here. We've also printed the type and the shape. The shape's important because when we use arrays, we use more than one dimension. So it's useful to know the shape. Now here we've got two arrays inside another array. So it's like two-dimensional, like a table. So we have an array 1, 2, 3, another of 4, 5, 6 inside one. So it's very similar like a two-dimensional list, but again more efficient. If we look at the shape, this is 2 by 3. We have two arrays with 3 elements in each. You may see the notation here that's slightly easier to read. So although the first and second array are on different lines, Python accepts that code. Now it starts getting more complicated when we use more dimensions. So here we have an array, two arrays inside an array, and we have that shape twice inside an array. So if we have 3 elements in 2 arrays and 2 of those. So you can see the shape, we've got 2 or 2 by 3. So with the square brackets, it's starting to get a bit confusing. So that's why we use data shape to understand it a bit better. Now we can perform operations, simple operations. So here we just multiply each element by 2. Data equals data times 2. Or we can even just add 2. So very easy to perform operations on each item. Now here we've printed the first array, data 0, the second array, data 1, and also we can access each element. So data 1, 0 would be, using those index, would be the element 4, the element 6, the last element would be data with index 1 and 2. So that's numpy arrays. We can create them full of zeros, for example, so just 4, 2 by 5, so we can use the shape to create the numpy array with more than one dimension, or even ones. We can use a range, which is a array-based version of Python range, and we can also reshape. So here we've created 12 elements, reshaped into 4 by 3, and then reshaped them by 2 by 2 by 3, we've slightly changed the colour of the output to make it easier to understand. But these are the outputs when we change the array of 12 elements to a shape of 4 by 3 and 2 by 2 by 3. We can also reshape back, so here we've got 4 by 3 and back to 1 dimension. Now what about a pandas series? So here we've got a list and we've changed it into a pandas series. If you look at the output, we've got the 10, 20, 30, 40, 50, but instead of being horizontal and like a list or an array, it's vertical, it goes down. And also we've got this 0, 1, 2, 3, 4, it's kind of like the index written as well. We've also got the data type at the end. So this is a bit more involved than our simple list or array. Now we've put this with the array to show you the difference. Here we've got the numpy array which goes across, and we've got the series that goes down. The same elements, 10, 20, 30, 40, 50, but can you see the different structure? Now if we output the types, we've got start off with X as a list, then we've got the numpy array, and then we've got the pandas series. So using the type can show you what we're actually using, because it can get confusing if you move from one shape to another or you have output from some code. We also can see the shape, the numpy array and the pandas series. Now we can specify the index, so here we've got 10, 20, 30, 40, 50 as we had before, but now we've created the index A, B, C, D and E with it. You can see them on the output. We can create a pandas series from a dictionary as well. So here we've got 3 students and their scores, and we put that in a series. You can see that in the output. Here's the same dictionary and a second dictionary. They're both the same with slightly different scores, but the same students. Now we've created 2 series here because we're going to put them together. So here they're just 2 separate dictionaries put into 2 series. Now we can add them with this data with the headings, if you like, English and science, which are like the column indexes, and put them in a data frame. So we can put series together to make a pandas data frame. So here you can see we've got English and science, we've got the 3 students, we've got their scores. So it's quite similar to a table in Excel, for example. So let's look at pandas data frames. So here we've got some scores, we've got English and science as the column headings, and each column is marked with an index here 0, 1 and 2. We can see that in the output. In this example we're going to access the first row. So we've got df, which is the data frame, .loc, and 0 is the index for the first row. And you can see that with English 81 and Science 68. The name is the index, which is 0. We've also got the type, which in this case are integers 64 byte. We can access more than one. We can slice. For example, here we've got 0 and 2, the rows 0 and 2. You can see in the output. And here, instead of just using the default index of 0, 1, 2, 3, etc., we actually specify the index. So here we've got Mary, Mocky and Sai, and you can see in the output now we have our data frame with specified indexes. Now we created all that data, but you might have data in a table, in an Excel file or a comma separated value file. So here's an example of some data in a CSV file. Now we can insert that into our code very easily using a read CSV command and the file name. And here is our output. Now we can start looking at different parts of that. Here's just the examples. The first example slices the first row, the second one slices the first column, and the third one is an example of slicing the first elements in the first 2 rows and 2 columns, or the first column with the index. So we can see from our data before, we had the marks 85 and 73, the first 2 rows, and we've got them in our code of the column called mark. So these are just examples of how we can access different parts of our data. So data series, we can put into data frames like columns in a table where we can index and slice our data. So in summary, a numpy array, we can create different types, we have different shapes and sizes, which we call dimensions. We can perform different operations, we can index and slice, different types of mathematical operations, and if you want to get into more detail, we can use these arrays in different dimensions. So we can use them for matrices, for example. And once we use them, then we get into things like deep learning and neural networks. So we can use data science and numpy for quite advanced computation. Pandas the name comes from panel data. You can see we use structured data, and we can again use indexing and reshaping and slicing and operations on our data. Now here's a list of differences between pandas and numpy and where we might use one, where we might use the other. We tend to use data frames, and we do use the numpy array when we use this data in frames. So we can use them together. There's quite a lot more when we come to arrays and data frames and how we use them. If you want to know more, leave a comment and say what you would like to learn. In the next video, we'll look at these data science data structures and why they're more efficient than our Python list, for example. That will come in the next video. So if you want to know when that's coming out, subscribe, click that notification bell, and then you'll know when that video is released. If you've gained anything from this video, please click a like, because that helps us a lot.